I can see the types of the solar power. Yes, before it was on the first page, so now I
Uh,
think it's
is now clear now? Is on the
yes.
types of
Now
solar
I
power plant, I think so. Yeah, if I am getting stuck somewhere, the PPT is stuck somewhere, please let me know, okay? I think on the types of solar power
okay,
plant
sure,
now.
sure.
Okay. Okay, let us go with the next part, that is the solar panels. So we know the solar panels will work as in photosynthesis, like as in our plants, where our plants will extract energy from the solar rays, and they will convert their that light energy into their useful energy. In the same way, we are using the semiconductors, that is the solar cells, that is made up of an silica, or that will be so there will be a complete different mechanism over there, that is a doping pn junction that will completely take 1 hour class or 40-minute class. So in when we are going into the complete class over there, I will completely explain how the pn junction will work, how the electron movements will happen. In the same way, I will just go with the basic introduction about that. So when the solar rays will be falling onto the solar panels, the electron movements will take place. That electron movements will be captured and into the form of DC current, and then it will be converted into alternating current by using the inverters. This is the basic understanding of any solar panel, any kind of solar panel, right? Um, this is the basic about the panel. And next, please let me know if if I'm changing. You can also see the different slide. Can you see the selection of PV module and technology? Can you able
Yes,
to
just
see?
now we can switch it. Okay, just when you switch the page, just any tell us, then we can see any yes the switching or not.
Sure, sure, sure. Sometimes the network
Okay.
connectivity issue. Selection of the PV module technology. If you are in the field of solar or if you are not, this is the very important part of solar energy itself. So the PV technology, we do have a multiple solar panels in the field of solar. To understand which one is the better one, that is a complex thing. So the selecting of the right PV module technology is a crucial for optimizing the performance of the cost effectiveness of the solar power system. Okay, so here you might have been seeing that there is a panel which has the light blue color or a black color, that is a monocrystalline and the polycrystalline panel. So still in India or anywhere in the world, still we are using, moreover we are using the monocrystalline panels. So there are the different kinds of PV panels that is being utilized. That is a thin film and the multi-junction type. So someone has said that he is from the Saudi Arabia. So the temperature of that area is very high. What will be happening if I using the polycrystalline or monocrystalline solar panel? These solar panels will not perform, or it will not produce energy that what we have been installed for. Let us see, if I am installing an 100-watt panel, that panel at the temperature of 35 or 45 degrees Celsius, that glass temperature will increase to 65 degrees Celsius. At that point of time, your solar panel will not even produce more than 25 watt. So you're seeing the difference, right? If you have a good sunlight, if you have a heavy temperature, if you have high temperature, your solar panels will not produce any amount of energy. This is the major problem that we are seeing in the desert areas, like as in Saudi Arabia, like as in India, Rajasthan, in moreover in many parts of India and the Australia as well. So we are seeing this kind of issue. That's the reason our monocrystalline panel technology is trying to improvise there to perform better in the high temperature condition. So to fight with that, so there is another technology system as well, that is a thin film solar. Have you heard anyone about the first solar company, first solar, and like Bright? Someone? No. Okay, the first solar is the company is an US company where it will produce only CDT panels. They will produce the other panels as well, but they will produce CDT, that is cadmium telluride solar panel. Cadmium telluride solar panel, which has the less, like as in very least amount of performance degradation at the high temperature. That's the reason in the countries like as in India, in the region of Rajasthan, Karnataka, or anywhere in the Tamil Nadu, or anywhere in the Saudi Arabia or in the Australian region. So we will be using the CDT panels and the CIGS, that is cadmium, indium, gallium, selenide, and amorphous. Yes, it is there, but this panel is completely failure in terms of the installing in the commercial or domestic. So the CIGS and CDT panels are most widely using as of now in the high temperature regions. So if you see one temperature, like as in 1 degree of temperature increase, your performance of the solar panel will decrease around 0.5 percentage. This is for the monocrystalline. When we are using the thin film solar panel, that will reduce to 0.2 percentage of. So there is a lot of difference in there. So that's the reason if there is a high temperature area that you had to go and you had to select a best suitable solar panel. So, if you see, if there is an rainy, like as an, if you have you known about the Bangalore condition, Bangalore climate, if you know someone about the Bangalore condition, so for that condition, which is the best panel that will be utilized? So, at that time, you can go with the polycrystalline. So in Bangalore region, we will be not seeing that kind of huge temperature. It will not go beyond to 32 degrees Celsius. At that time, your panel temperature will be not more than 40 or 41. But at that temperature, these panels will perform very high, and they will give, if you have a 100 watt of panel, it can produce up to 110 as well because of the low temperature, high radiation. The radiation, that is the energy, comes from your sun. You should be calling not as a radiation, it's an irradiation, right? And there's a new type of technology that is being using, that is multi-junction type. It is still under work, and it is not available directly available in the market, but monocrystalline, polycrystalline are widely available. You can able to purchase anywhere from the in the world. You will get this panel, but the thin film panels, you have we have very few manufacturers. But if you have any planning to install that kind of solar panels, or if you have that in your designing concern, yes, you can install it, but don't go with the amorphous crystalline. And I think that would be understanding of basic understanding of the solar PV technology. Let us go. So as of now, everyone know about the monocrystalline solar panels. So we do have a two different types of monocrystalline as of now. So there will be an N type and P type. These are the two difference. If you are going to design of any system, or if you are an homeowner, if you're going to install any type of installation on your roof, like as in monocrystal 5 kilowatt, 10 kilowatt, 3 kilowatt, or you are going with a monocrystalline solar panels. If someone is asking that I will install the monocrystalline, you can ask them which type of panel that is this N type or P type. The N-type solar panel is kind of low production cost, and the doping in the terms of the technology for the doping, like where the sunlight will be falling onto the solar panel, where the electrons will get excited. It will it will move very fast. At that time, we will be adding some doping to that. That doping is called boron material. If we are using the boron material, the cost of the solar panel will be less, and the production will we have the many manufacturer of that kind of solar panel. You will get easily, and the degradation is very high for the n-type solar panels, and the cost is also less. And the new technology, that is p-type, where we are using in the manufacturing, we are using for doping. In n-type we are using the boron, but in p-type we are using like as in phosphorus. So where the cost of the solar the manufacturing cost is high, but the degradation factor is very less. If someone says that this panel will run for 25 years, I think you have been heard that the panel that will run for 25 years, you can ask the warranty for that. They will say that will run for 10 years, not more than that, or 12 years. After that, there is no warranty on that, because it's an n-type solar panel, where that they can't give the warranty on that. If you go with the P type, they will give warranty for 20 years or 22 years. Please check while you're going to design this kind of solar system, right? I think this is a good understanding, or if you are going with any installation or you are going with any designing of your system. So there is a lot of design that come across, but that is fine for us of now to understand the difference in between there. Okay, so next we are, can you able to see the next slide now?
Yes, we can see.
Okay, great then, great. So we are understanding the basic scenario about the PV system sizing and the connection. So here we will be having two different kind of solar plants. One is domestic, commercial, and the large scale. So designing will also get difference in between there. So in the large scale and the commercial, we do have a good understanding. We need to do the assessment. We need to do the overloading analysis, uncertainty, hydrology analysis, basic engineering, grid connection assessment, energy yield assessment. All this will come across while we are doing any solar system design. But if you are going with a domestic energy, domestic installation, I will go with the basic level so that it will be easy to understand you all. So if you are going with any home, like as consider my home, if I have a sanction capacity of around 10 kilowatt, so let us it's just a scenario based kind of understanding, so that will be easy to understand by yourself as well. So to calculate the energy consumption, if I'm going to, or if I'm going to install an 10 kilowatt, why I'm going to install the 10 kilowatt? Is necessary to install the 10 kilowatt? Is that necessary? No, we don't know about it. So first we have to understand what is my consumption, what is my daily usage. So you can get the usage if you have been if you have been like you can take over the all the bills of previous 1 to 2 years, and you can divide it by 12 and you will get the actual consumption of your home. But meantime, if we can able to understand that I will be using this kind of appliances. Yes, if you are going to be an engineer, yeah, please, this is a crucial part. Try to understand. If you don't understand, please ask me. So that will be the this is the crucial, that if you are going to understand any kind of system, okay, please try to understand this. If I have a consumption of around like I'm using a TV, fans, lights, a refrigerator, okay, and AC for around 4 hours, and like as an Wi-Fi router, laptop. So we do have around five appliances over here, where my TV can consume around 40 watt. If I'm using LED TV, LCD TV can consume around 60 watt. If I'm using LED, 40 watt. That one is the 40 watt. Let me try to make a calculation over here. Okay, let me try to open up calculator. Okay, not calculator, Excel sheet. Okay, can you able to see the Excel sheet now? Excel
No,
sheet.
sir. Yeah,
Okay.
yes, we can see it.
Yes,
Yes.
Excel sheet. Okay, great then. So Excel sheet. So this is my home of 10 kilowatt is my sanction capacity. Please make a note of it. Sanction capacity is a crucial word. Sometimes if you're going for any interview, they will directly ask you sanction capacity. If you don't know that, you can't design anything. So that is a maximum amount of energy that the home is asked for. If we are consuming more than 10 kilowatt at that time, you will get a penalty of it. Yes, surely. If you want to check your bills, you please check. There is a sanction capacity that is 3 kilowatt, 2 kilowatt, 5 kilowatt, 10 kilowatt, 20 kilowatt. If you are consuming more than that, you will get a penalty on that. So that is the maximum
Sir,
of.
sanction capacity means my home total load or what? My
Yes,
total home
it's
load and sanction is same or different?
so it's an load where you have asked to the grid company. So I may use this 10 kilowatt of my home load. It will not go beyond to that. So you will be not consuming more than 5 to 6, but you have taken the extra amount of sanction load. That if I am using this amount, if I am using this 10 kilowatt, you will not get a penalty. If you are going beyond to that, so that there will be a penalty on this. So why they will give the sanction over here? Okay, I think some of them are trying to join over here. Let me admit them. Okay, let's come on the topic now. So, if there is an community over here of 40 to 50 homes, or you can consider as an completely an village or an community where we have the 100 homes. So, for that 100 homes, we will be having, and the government or an company will be having that this is an average load that this community can take up, right? So they will install one transformer. So the transformer is considered to be an 1000 kilowatt or like as in 1 megawatt, right? So that 1 megawatt will be utilized to the complete community. If you are using more than that, it might be can underload or overloaded, right? At that time it might can get trip. So before going to install anything, so if you are in your home, there is an asked capacity, there is some capacity. Some will, if you have a single bedroom home, that capacity will not more than 3 kilowatt because you will be not consuming more than that. So if you have a, four bedroom or something like that in your home, or if you're using the pumps, lift or anything like that, that would be like as in 10 kilowatt that you have been asked for. You should not be go beyond to that. You will get penalty. Yes, this is an sanction load before going to ask for any solar system, like as an interview question. Okay, this is the 10 kilowatt now. I'm having. So I may can directly install 10 kilowatt or I can depend on my consumption. As I said, I'm not using more than 6 kilowatt. Let us see TV. It will take some time. Please bear with me, guys. TV, like as in fan. Is it fine, right, that I'm trying to explain this scenario to all you guys, or should I go around this? Fan, TV, LIG, HDS lights. Should I know? Oh, there is no response from anyone. Should I need to be a little bit faster or I'm going very slow? Okay,
I
refrigerator.
think you should rise as you yes a bit speed up.
Okay, okay, sure, sure. Yeah, sure. I will try my best because this completely designing system, right, of the solar plant, yeah, it will take some time, but I will try my best possible way to speed up this process. Okay. Like as in refrigerator, what I was asking, Wi-Fi router. And then next, TV, fan, refrigerator, and light. If anything I'm missing, AC. Okay, okay, let's see now. 40 watt, 60. Okay, sorry, it will take around 80. Lights, we do have LED lights. If we are using 4 to 5 light, each light can take up to 20. That would be considering as an 100 watts. Refrigerator, if you are using a new technology, new inverter type technology, it will not consume more than 250 watt. Or like as an if okay, if you can take 350 watt, that would be fine. Wi-Fi, that is around 15 watts. AC, one if you are using 1.1 ton, that will consume around 1.5 kilowatt. So this is your wattage now. I'm just giving a complete brief about the designing of the system. Okay, so your consumption is 2.2 kilowatt, approximately 2.1 kilowatt. So, amount of hours that you want to run. If you want to run the system for around 10 hours, so that it can be up to okay, that would be 20 kilowatt. So 20 kilowatt is the maximum amount of energy that is required to run your appliances. So make a note and keep in mind this is an 20 kilowatt. Okay. So let us go ahead and we will try to explain this scenario as well. So
So
make
you
a note.
mentioned the time is 10. You mentioned 10 hours, right? Like
10
10 hours.
hours, just
Like you
10
mentioned
hours,
the.
just an assumption of 10 hours. You
Okay.
are using all this. So there will be
Okay.
a different time scenario. That is, I will run the TV in afternoon around 2 hours, in the evening from 6 to 10. So there will be a different time scenario. According to that, you have to design it. I have just given it for 10 hours. Okay. You keep in mind that is I have a load of around 20 kilowatt. Let us go ahead with the next point over here. Determine the daily usage total energy requirement. We have done this to calculate the energy consumption. This is the total energy requirement. So the next is the solar panel requirement, total watt hours needed. So we do have the total watt hours needed, that is a 20 kilowatt, right? 20 kilowatt is our watt hour is needed. So peak sun hours. So this is an very crucial, and it is somewhere many in this field of solar will miss out this concern. So in the field, when you are designing any plant or any domestic, small, higher, larger, whatever it might be, so you have to understand the peak sun hours. So the peak sun hours is like that from 9 where our solar panel has been installed right at some tilt around if we consider on Bangalore condition as of my hometown, it will not more than 12 degrees. And when we go for around the Delhi, it will be around 35 to 40 degrees. I don't know exactly about the Saudi Arabia and different condition. So there will be a different tilt angle according to their latitude and the longitude, depend on the sun direction. So this peak sun hours is like that, where our sun will be directly perpendicular to that solar panel. It will not always be perpendicular, but it will be nearby to that, where our solar panel will generate maximum amount of energy. So that would be considered the sum in the field in the larger scale panels. We will be having fixed and tilt. There will be a different model structure, but in the domestic where we are considering, we are using the fixed type of structure. So where we need to consider that is from the 9 a.m. to 2 p.m. That is 10, 11, 12, 1, 2. That is around coming around 4 to 5 hours, right? So this is the peak sun hours where you have to consider the design. Not like that from morning 6 to evening 6. Never. If you do that, your system always be an failure design. If you answer like that in the any question in the any like as in any interviews or something like that, that is an failure answer. So you had to inform that there will be a perpendicular, where our sun will be perpendicular to the solar panel, where it can produce a more amount of energy when it is compared to the other time hours. So but there will be production, but it will not consider in the field of design. So my panel can produce, like as I said, like take as in 5 hours. Okay, we have again back to this now, 20 kilowatt divided by 5 hours. So what is the amount that we are coming over here? 4 kilowatt, right? Is that fine for you everyone? Can you see that? Are you getting onto this point? Anyone?
Yeah.
Please respond. This is the major concern over here.
Yes.
Yeah, great,
Yes.
great.
We are getting to the point.
Yeah, getting to the point. That's great. If you're understanding this, that is a great thing. So this, what is this? 4 kilowatt. Anyone can answer this. What is this 4 kilowatt which is showing up?
Oh, that is the maximum kilowatt delivered by the solar panels at the peak time.
Exactly for the peak time. So 4 kilowatt solar panel need to be installed for the system to generate 20 kilowatt of energy. Done. So we have the consumption, we have the consumption, We had the total consumption of the day and we had the total consumption throughout the day. According to that, this is the kilowatt the solar panel is required. So 4 kilowatt, you can use 4 kilowatt or 4.5 kilowatt. That would be fine. 4.5 kilowatt, that is where we have come across the panel capacity. We are on the point, right? So now the number of solar panels is required for 4.5 kilowatt. If you're using 500 watt, you just divide it, or if you want to go with the 250 watt solar panels, whatever the type of installation, if we have a large space on the roof, on the land, whatever it might be having, if you have a large space, you can go ahead. If you can install the lower wattage panel like 250 watt. If you have very less space, you can go ahead, you can install the higher wattage, that is 650 watt of solar panels, right? Is that fine for you, everyone? Are you getting this?
Sorry,
Yeah.
sorry.
Yep.
Hello?
Yep.
You have just, please, can you just explain what you said now? You said if you have large space, how do we determine the number of solar panels,
Exactly.
on the roof? Yeah.
Exactly, exactly. So we had to
Okay.
understand what is the space that is there on the roof. That is called as an feasibility, the site selection. That we will come across to that. That is for the feasibility test, whether we have space on the roof that we can able to install the solar panel, whether we can install on the roof directly or we have to install in high-rise panels. So it's always depend on that. So if you are installing any type of solar panel, like if you're going with a Trina, Canadian, Jinko, whatever you might be having in between there. You have the 500 wattage of panels and 650, and around we are getting around 700 watt panel. This 700 watt panel consumes an less amount of area. It is an kind of multi-junction solar type of panels where the quality of the monocrystalline cells that has been using is very purest. That's the reason the panel capacity or panel size or panel area will be lesser when it compared to the lower size of the solar panel. When you're going to see, if you go to any panel distributor, they will show you what is the size of the 250 watt solar panel and what is the size of the 450 watt. If you want to just check, let me try. Okay, let's go ahead. Let's go ahead. Jinko, right? Uh, like as in Trina 5, it's like as in 650 watt data sheet. Okay, 650 watt of data sheet. Okay, 670 watt. Let's see, 670 watt. Can you able to see all? Can you all able to see this? The data sheet
No,
which I'm showing? No?
no.
Let me try to show that. Okay, I need to download that. Wait for a minute.
Or it might be shared only one particular screen instead
Right.
of complete.
Exactly, exactly. Let me download that. Hello, can you able to see view this page?
Yeah, now it's okay. It's good.
Yes, we can see.
Yeah, you can see that, right? So this is a 670 watt of panel where the size of the solar panel will remain same, but the wattage is changing over here. 645 watt, the size of the panel is same. 675 watt, 670 watt size of the panel is same. So, as per your question, this is the answer where if you go with a different kind of solar, so if you have this space, you can able to understand this scenario. I think that is the answer for your question. I think someone has asked me, right? So if you are going with a higher wattage, so with the same space, you can install the higher wattage, or if you have a more space, you can go with the 645 watt. So there will be a price difference in between there. So it might be price difference between like as an 1 rupee or like as an minimum difference, but will also at the end of the day that cost will make much difference. So make sure to understand the scenarios and the pricing of the each kind of solar panels. If you are going with the 645 watt, 675 watt, what would be the pricing difference? Okay, let us go ahead. So this is the complete solar training, right? It will take a lot of time, but I will try. I'm trying my best to okay, a window. Sure. Let us get back to this presentation again. Okay, you got the number of panels, panel capacity, peak sun hours, total wattage needed, energy requirement. Do you have any doubt over here, guys? We all are on the same page, right? Hello? We all are on the same page. You got
Yes,
everything?
yes, yes, in the same page.
Okay.
Yes, so you can see the PV system sizing and the connections
Okay,
on the
everything
second.
everything looks fine. So this is the basic understanding about the system. So you have the clear picture that it will go like this. It isn't complete PV into I, or PV is equal to I, like I said, sorry for that. V into I is equal to power. So if you know this scenario, you can design the system. But there are a lot of other scenarios that come across. That is for the higher wattage kind of solar system. So let us go with the next slide. I don't want to don't waste the time over here with explaining the simple things. So if you have a question, you please ask me. I will answer to that. Okay, off-grid system. Off-grid system. I have explained you the hybrid system and the interactive grid connected system. In the off-grid system, you are not connected to any grid, or you have been using a three-wave switch that you have it completely disconnected with the grid. So this system will operate on the batteries and the solar power. How this will be running? So as you say that we have calculated around for 20 hours, like as in 20 kilowatt divided by 5 hours, you got a 4 kilowatt of energy, 4.5 kilowatt. But over here, this will be the complete different scenario with the battery capacity. They divide the total wattage hour by the battery voltage, then multiplied by the number of days. That is called the autonomy. The days you need to power without the sun. This is the main thing that you need to understand. And if you are going with the batteries, so moreover, the battery is not at like as a good in the market, but slowly it is increasing. But if you know about it, you can get into any upcoming industry, that is GrowWare, SunGrow, SolarEdge, Enphase, Tesla. They all are working into this scenario now, interactive grid connected system. So depth of discharge, so it is completely on the battery, so that we can able to give an programming that the batteries will not discharge to certain amount, like as in 40%, 50%. If we are as this is for the lithium ion batteries, sorry, no, not for the lithium, this is for the lead acid, selenium base, red oxide. These are the three different batteries where we can use the 60% of battery discharge, because if we go beyond to that, it is very difficult to pick up the batteries again. So we had to visit site to check for what happened to the batteries. So for the lithium batteries, iron phosphate, the new technology batteries, we can discharge to 0% and we can able to charge it again. That was not possible by the conventional batteries which we are using, right? So in your car battery as well, if your battery is completely discharged, what you will do, you need to again charge the battery from somewhere else. Again, you have to install on your car or in the solar batteries as well. But these lithium batteries are kind of different, where we can discharge to complete to the zero. Again, we can charge to the 100%. So again, we can give the depth of discharge, but it is not necessary in the new technology batteries. Okay, we will go with the next slide now. Okay, the PV system connection. We have gone to the PV, number of PV panels that is required. Now, the type of connection to the solar panels. The purpose, what is the purpose for this? It's depend on the inverter again, the type of input voltage that is required to this for the solar panels. If it is requiring, if consider my panel can give you 20 voltage from each panel, but your inverter is asking for more voltage, like as in 120. What you will do, you will integrate it and you will increase the voltage. Or if you're like as in, if you have the capacity in your inverter, you have it 40 volt of input, but you have a good ampere input that they have given. What you will do, you will just parallel it. This is the type of connection that is required in the field of solar. So it's depend on series parallel connection again if required. So for that I have just added one image for it to understand in the simplest form. So my inverter need of around 120 voltage. So that I have the like as in 20 20 20. What it will give, it will integrate over here as it shows in the series connection, increase the voltage while keeping current in constant. In parallel connection, the current will keep increasing, voltage will be constant. This is the major concern. And any design of any plant, of any domestic commercial large scale, this is the series this type where the increase of the voltage is necessary. What is the voltage over here? The voltage and current, what is the difference in there? Voltage, current and the power. Voltage, if any someone can say in the simplest form, what is then voltage? Voltage, to understanding in the layman words, it is an potential. It's just an potential. And I, that is current, is can consider as an kinetic energy. Like as a dam, in your dam, in a high in a water dam, so the level of water is high. That is your voltage. That is your voltage. The water which is flowing from the dam, the amount of small amount of water from the dam, that is called current. If you have a high rise dam, if you have full water, the water will flow very fast. And if you have a low, it water will flow with a lower speed when it compared to the other, and it will not go more than some kind of distance. If you have a high, it can flow like as an large like as an much distance. And this is the basic example that I can give you for. In the same way, if your inverter is a little bit far away, you can go with the integrating of the solar panel. That is a series connection. You are increasing the potential of the energy where your current can transfer easily to the inverter, right? So if you have a inverter nearby to it, and your inverter has the availability that you can able to go with the lower wattage and the lower amp, yes, you can parallel it. So you no need to send anywhere over there. You no need to travel. So you have discharging there itself, then and there itself. That you no need to integrate or increase the voltage because you have the inverter there itself. That would be the best possible, that you are avoiding the lossage of the current over there. Whatever the traveling, if it is current is traveling from one point to other point, there is an lossage. This omicron, that losses is a complete different scenario. That is a complete different calculation when you are going for the assessment. So that is a complete 1 hour scenario, 1 hour kind of complete discussion where we need to interact with each other. You have to ask question, then only I can able to answer that, then only we can able to get into this, that kind of scenario in the losses, that you have to also work on that. We can able to get into the complete understanding of the system. So PV panels in series, this is again, if you are going with a small domestic, sometimes if you are using it to, as I said, you can install 500 watt panel, but you are going to install 100 watt panel, what will happen? So you had to go with integration, difference, like as in series, parallel. You had to attend, then you can go to the inverter. This is the way how it will work. So I think that you are understanding this scenario of understanding the voltage and the ampere and the output power. Okay, are you getting this?
Yes, I have one small one.
Okay, let me get back.
What would be the maximum voltage can be developed by a single panel? Is it?
Let me give you the one data sheet that I have shared to you, right? Let me share that to you, okay? So that everyone can understand that question.
And is it the same voltage can be done
Uh,
various wattage, or how it would be?
no, that will be kind of different. Let me try to share you. So every panel has its different voltages and different current. Let me try to share you this. Okay, can you able to see this electrical data sheet? Electrical data? Can you able to view this? No?
I can see the high power up to 670 watt.
High power up to it is not loading.
Sorry? Hello, we are seeing versus back sheet.
Ah,
Uh-huh.
Okay,
yeah.
you got this. I have just
Yeah.
opened the two data sheet over here. In between that, I got confused. Okay, voltage and the current, that will be completely different for all the solar panels for the different wattage. That is the designing. So uh, there where you need to work on that. So you can see the open circuit voltage. So the understanding the open circuit voltage is 45. Okay, and the short circuit current is 18 watt. So that is 45.3, 45.5. The small difference will also make a lot of changes over there, but for the different company, for different wattages, the voltage will be varying. So you have to work on that, you have to calculate it. That is a different calculation.
Got it.
It's completely kind of designing. So what we have worked, what we have been working, right, is on basic understanding. If you're going with the designing with wattage, voltage, as I said, you're right. The one thing that I was showing to you guys regarding the temperature, that will cause changes over there. Let me share you. Okay, can you see this? The temperature ratings. Can you see this temperature ratings?
Yeah.
This is the temperature rating at the time of designing. So the less amount of engineers or the less people will know about this concern. But if you are knowing how to what this would be, see, you can see the temperature coefficient for the voltage, right? For every increase of temperature, you can see the 0.25 percentage of voltage reduction, 0.34 percentage of power reduction. This is what I was trying to say if you are increasing the temperature. So nominal operating temperature is 43 degrees Celsius. If it is going beyond to that, you will be saving severe amount of degradation of solar panel of Trina Solar. Vortex patched, monocrystalline. Okay, let us get back to the topic now. Let me get to the PPT. Okay, we are back to this now. Anyone has some question? Please let me know if you have any question. So if you have a question that everyone can understand, what would be the answer for this? What is what they are trying to understand? Yes. If you have any kind of issue or question, please let me know. Everyone is learning over here. It's not like that. Everyone is something like that. Know that we are just watching it. It's kind of learning session. Okay. I think everyone is done with the solar panel PV series connection, parallel connection. Okay. Fine with that, right? Let us go with the inverter section now. Inverter section at the time of introduction, I said you this is a very crucial that you need to understand over here. So we do have three different, oh no, so four. There was a power optimizer was not using. Still, I have not used that, but I have used the string, micro, and the central. The central inverters are completely very large scale project, very large scale inverter. It would be like zero point 0.5 kilo, like as in 500 kilowatt to 1 megawatt, 2 megawatt, 2.5 megawatt inverter, a single inverter. And whereas the string inverter has, it will start from 4 kilowatt, 5 kilowatt, 2 kilowatt, 10, 50, 100, 200 till 250. You can say the string inverters, not more than that. It's an kilowatt of energy. My house, and at the time of my reference, which I am giving the 10 kilowatt right per home, the string inverter, I can use the string inverter for my home. I can't use the centralized inverter because it will be too heavy for me. It is used for only for the megawatt project, that is for the large scale project, not for the domestic or for the commercial. For the domestic and commercial, you had to go with the string, power optimizer, or an micro inverters. The micro inverter and the power optimizer is a very new, it's not a new, it was there from last 10 years, but it was less like as in publicly available. Now this inverters, optimizer, and the micro inverters are widely using everywhere around the world. So micro inverter is an inverter. A single inverter will be installed each panel, each panel. As I said you over here, PV panels in parallel. So there is no losses over here. If you install the inverter, one inverter back to the solar panel, what would there? You are not seeing any losses in that solar panel. That would be fine. If you are doing this integration like as in series and you are traveling somewhere to the inverter, you will see the losses in there. If you install exactly backside to the solar panel, yeah, there will be no losses from the solar panel or DC loss. So these are the type of new inventions that are coming. So understanding of the each scenario, which inverter is better for your solar system, understanding is very important. And it will depend on the economical base as well. The micro inverters are a bit high price, string inverters are fine. The power optimization is in the mid level. You can use like as in SunGrow, GoodWe, or like as in Solar Edge. They have their own power even the Huawei has the power optimizer and the string inverter. A lot of companies are there, like as in let me name some: Solar Edge, Huawei, good way, you just name it, that company, Snyder Electric. A lot of companies are there, so you had to make sure that which company is better and who is providing service to you in your area, right? The service, the company's presence should be there if you're going to install. As I'm an installer, as you are as an installer, if you are an homeowner, if you are going to install as a designer, yeah, they should be there because these inverters will face a lot of failures at the time of the working condition at any temperature. So please make sure to understand which inverters are better. So we will discuss a lot of things about this type, different kind of inverters in future. Let us go ahead with the site selection and the plant assessment. Okay, if can you someone try to if you have done any solar project, what you will see when you are going to install, or if someone is asking for you install an solar panel, what you will see the basic things. Can someone try to answer this? This is where our training lies in. What is the basics? What you will understand over here? If I'm asking, if you are an installer, and if I want to install a 10 kilowatt of system, what you will see first?
Yes, actually, first we will check the how much the load of the like any user, how much the load of his house or his building. On base of this load, then we can make the calculation as you did the calculation in the Excel. So based on this, if you tell us like he has how many lights, how many fans, how many refrigerators, based on this we can calculate the total load, and then we can go for all this mathematics which you did, and we can decide how many panel we need, and in this way we can decide.
Exactly. That is for completely domestic
Feasibility also will check.
exactly, feasibility. Feasibility is the major thing in the field of solar. So any site selection or an plant assessment. First, if I ask if someone let me take one example. If Shrikant is there, okay? Shrikant, if he Shrikant has a home in somewhere in the somewhere around the in India, some like as an Orissa, okay? He has an area, he has a very big house, he want to install a 20 kilowatt of system. So it's a big system, right? I have just given the example of small system over there. If you have something like that, if Aftab is going to install, if Aftab is visiting to site, what he will just check, oh, I need, what is the location of this home where he wants to install. First, we need to check what is there sun, what is the throughout the year, what is the sunlight, whether we have the good sunlight over to their location, or it is completely rainy season around for 6 months in a year. If you have a 6 months in a year, if you have a rainy like as in winter, you are not getting sunlight, it is a failure project. If you are doing that, you can directly inform that. So this is the scenario where you can generate 6 months of electricity. After that, you will be not producing any amount of energy. But you had to understand the sunlight, what is the climate of that. This is the first thing before going for any installation. Okay, the second thing is um, the topology and the land use. If you are going with a commercial, so what is the kind of land over there? It is an wetland, dry land. So these are the like as in a lot of things that you need to understand. So are you getting into this? What I'm trying to say over here? Anyone?
Yes, 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 getting you. Yes, yes,
Yeah.
very well getting.
Yes, yes.
So what is happening over here is to understand the simplest thing over here that will make a lot of understanding. So the topology where we need to check is someone has asked about the roof over there, right? What kind of roof that they have? In majorly, if you are going for the any kind of roof like in Europe, you will be having like as an canopy type of roof. It is not a flat roof. In India, you will be seeing more like as in flat roof. In many countries, it's not like that because of the rain or snow or something like as some other issue. The flat roof will never be unflat. So understand this topology. So we need to get into that first, and whether we can use any land if he has, what kind of land, any elevation is there, is suitable for the solar development, or if we can able to see this is the site selection is not for the domestic, it's for the large scale project and for the commercial project. So understanding this kind of generally you understand, try to make sense in your mind. So you will be trying to understand, oh, this is the thing, yeah, so that I need to know about before going to install in any kind of solar system. Yeah, topology, the type of roof or type of land, whether it is feasible or not, and the land of is this land or is this roof, is it can be utilized. Yeah, it depend on the government over there. Is someone, if you have a land, it is not like if I have a land, I can't directly install the solar plant over there. So we need to get the confirmation from our neighbors, NOCs from our neighborhood, and we need to get a confirmation from the government over there whether I can install the system, right? These all are the feasibility, as someone has said that feasibility is required. This all comes under the feasibility. Okay, next is grid access, the proximity or to the grid connection. Grid access, whether we have a grid easily available. See, in the domestic, obviously there will be a grid, there is no issue at all. You can directly connect it and you can send it back. As I said, one example over there, if I have a community, like as in 100 homes is connected to the single transformer, okay, an area which is connected to the single transformer. So in the feasibility test, we will be considering this. If we can't overload the transformer more than 75 to 80%. If I have 100 homes, if the transformer capacity is like as in 100 kilowatt, just as example as an 100 kilowatt, we can't give more than 80 kilowatt on that. We need to check that as well with the government. Can we able to add this my solar system to your transformer, whether it is suitable. If they say it's suitable, yes, you can go ahead. You will have done with the feasibility, you have done with the confirmation, you have done with the other things. Yes, you can go according to that. This is the grid capacity. According to that 80%, yeah, you have a, if you have installed around 60, yes, you have around 20 kilowatt of availability over there where you can install it. Accessibility, whether you can able to, accessibility is like that, is easy way of the transportation, easy way of the utilities where you can able to utilize that. See, it's somewhere in the rural area where you're quoting the less amount of price for that, that will be a burden for you. It's depend on that. This is also comes under the feasibility. This all are feasibility condition where you need to understand. So depend on that, the feasibility, your system design will change, your system costing will change, the financial scenario will changes, and the environmental sensitivity. So if something is like that, the environmental, if like as an the protection of wildlife is there, or if someone is not agreeing that it may cause some kind of issue over there, you just please you need to check with your homeowner over there or an government officials over there. They will make you understand that, yeah, this is a feasibility where the environmental sensitivity connection is there, where you can't install the solar panels. This will also come under into this feasibility as well. Community acceptance, as I said, you, and the regulatory, legal and consideration, the permits, approval, and land ownership. If you are installing on the roof, there is no issue. If you are installing on the land, again you have to go with whether we have an option to do that, whether is there is a grid availability, whether we can able to transport. See, I have a substation somewhere of the grid company. If I'm installing this somewhere, so you had to transport this wires has to go in some other or some different, like as if different owners are will be available, landowners, it has to come over from there. So are there, everything is fine, there is no issue with them, you had to check, you had to take the permits approval, and you had to pay for that, then only you can install the system. This all things are comes into the feasibility. This someone, I think Shan was have asked this all things are in the feasibility and the plant assessment. This is called the plant assessment, site selection, and the feasibility. All these are same things. Anyone has some question in there? Anyone has question? Okay, let me get into the next slide then. Okay, the same thing over here with the plant assessment again, the initial screening, satellite data, where you can get the radiation data, right? As I said, you the radiation data, sunlight, and the climate. So we do have that option that you can get it from any REL, like from the ISRO. We do have a multiple the solar cast. They will provide you the radiation data of that area of that location. So where you can able to analyze and you can able to install and you can able to plan feasibility according to that. The assessment is just fine. The feasibility study, final selection. This is the where the balance, or you can say the compare the potential site based on the feasibility study. Select that offer the best balance of the solar potential cost and the feasibility. Again, the costing of the system. Do you have any question according to this? Any question? Any question if you have? Okay.
Hello.
Yep.
Sir, when we are going to install a solar power plant in an industrial area, so what parameters do we have to check first? Like transformer sizing also we need to check.
Yeah, this transformer sizing can, these details will be provided by the grid company. So there will be a substation available. If you go to the substation, they will provide you the complete detail about the transformer, whether you have an option to do that, whether you don't have option. We have the multiple different kinds of transformers available. It's an interactive or it's an unidirectional. So they will let you know about that complete details. You have to check with their substation, or you can see like as an assistant electrical
Discom.
engineer, Bescom, right? To Bescom. Bestcom, you just need to ask to the Bestcom. They will let you know they will let you know all the details about this, whether it is possible or it's not possible. They will say then and there itself. They will not take any time.
Thank you.
Okay, next is plant assessment. Again, the regular plant assessment are essential for maintaining the optimal performance. So if you have done that clearly, then your system will be performing very well. And then the next is maintenance and the optimal performance and the safety to run your system efficiently. It's in domestic, it is not that matter, but if you are going to install like as in 50 kilowatt, 60 kilowatt kind of system, yeah, this will matter. You had to optimize the system performance. So how you can optimize the system performance? Optimizing the system performance.
By visually inspecting the production of, sorry, generation of our power plant.
Exactly. We need to understand the performance ratio of the system, final yield. These are all the kind of performance analysis. Performance analysis. According to that, we need to optimize it. If there is something issue that is system is not producing power at a certain condition, at the high temperature or at the low temperature, you should be monitoring your system. There should be someone that should be monitoring. So according to that, you can optimize the system performance and you can utilize the much from your solar panel and the cost saving as well. Indirectly that will also save the cost and the safety improvements and the environmental responsibilities. These are the plant assessment that will come across. And the next is solar plant design. The same again, the solar plant design, you had to go with the assessment layout. So if you are going to install in any solar plant, if you want to design the solar power plant, this is what this course is about. We do have to consider the lot of scenarios over here. If you are installing, what would be the tilt angle, orientation, what is the distance between the each rows, what is an optimal distance between the each row. This is an designing part, complete solar system designing part. So how this whether is your solar panel is completely towards the south, due south or zero south. So according to that azimuth angle, like as in pitch, the all calculation will be going into the system layout. So you can see the panel orientation and the tilt, inter-row spacing, ground coverage ratio. What would be the ground coverage ratio? How you can able to calculate it? What is the like as in shadow analysis? How you can perform it? What is the basic calculation of that? So all these things that comes in around system layout, that is a complete calculation part. I can't able to give you the theoretical knowledge on this. This has to go with the calculation. You had to work on that. Yeah, surely I will assist you everything according to that to understand how you have to design the system according from the tilt, row spacing, shadow analysis, understanding of the PV, which panel, which what would be the height, inter height, everything will be um, like trained in the next course. Electrical design, inverter selection. So inverter selection we have already discussed, but we will discuss further in the plant designing. We will be discussing in depth about it, how you can select, what would be the MPPT, that is maximum power point tracking, how it can be, what would be the ports or their voltage, VOC, that is open circuit voltage, VMP, closed voltage, short circuit current. So all this consideration and the wiring. I can't able to explain you everything in the introduction part, but the wiring calculation, wire sizing, wire insulation, the grid connection, how it would be the, what would be the transportation, everything will come under the electrical design. Structure design, this is a complete different scenario. There will be a different kind of structures will be available in the market. So if you are going for the domestic, surely you will have to go with the fixed. If you're going with a seasonality, that will cost you more. Better you go with the fix. If you are going with the commercial projects, yes, you can go with the different kind of mounting structures that are available in the market. So you have to understand what would be the best possible structure that you can able to install it according to the financial analysis. So you have to be economical on that, right? So we will understand that as well. Performance monitoring, as I said, you monitoring system, the monitoring system, the performance ratio, utilization factor, final yield, reference yield, what is the difference in between there, and how you had to calculate, how you need to monitor, whether we can do it. You had to monitor from the monitoring sites, or you can do it by yourself. Yes, I will show you the each and every calculation of that analysis of the monitoring system. And the safety, what are the safety things that you need to concern? Yes, everyone who is working in the field of electrical, they will be knowing all the basics about it. But the safety in this field of the solar, what you need to check by using the data analysis which we are being done with the monitoring system, you will get with that. According to that, we can able to use uh, safety compliance as well. And the next is performance analysis. Again, like as I said, someone has asked me about the performance. That is the performance monitoring. This is the complete performance analysis. What would be the performance analysis over here? How you have to calculate the energy yield, system losses, degradation. So every electrical appliances has their degradation. You can't run away with that. So there is an degradation. There will be an losses. The energy yield, what I said, the reference yield, radiation, final yield, optimization, performance ratio, capacity utilization factor, all will be used over here, and the environmental factors as well. So the data collection software, there are the multiple software if you want to use, or if you want to do it by Excel, yes, you can do it. But the detail come across. If you're using one or two micro inverters, that would be fine. But if you're using a commercial where you have 10, 15 inverters, uh, there you have to use any kind of monitoring system. Okay, the benefits again the same, cost saving, decision making. So that if you have seen like that, what you have done is completely somewhere if you're giving a very good result, that will make you understand in the future project as well, that you can improvise it again. Or if you have gone somewhere wrong, you can understand where I have gone, what I need to do betterment in my future project. You will get to understand each and everything while using the performance analysis. Okay, maintenance part. So I think everyone is from the electrical background. So, regular inspection, visual inspection, what is happening with your solar panels? Is there is any on the solar system? You have to check any soiling is happening. If there is any shade on the solar panels, it will not produce any amount of energy. That you need to understand that. So you had to do the visual inspection, electrical inspection. You had to check the earthings, earthing calculations. Everything will be discussed later. What about the cleaning of the solar panel, inverter cleaning? The cleaning of the solar panel is very necessary in the field of solar. If you clean regular time of interval, your system performance will be good. And you have to clean the inverter, that will decrease the circuit increasing temperature. It will keep into the optimal way. So that you have to keep in mind. So in the central inverters, we have to do it every month over there. But string and the micro, it is not necessary. Preventive maintenance. So you had to check, you had to keep the thermal imaging, you had to check the overheating of any connectors, any AC combiner box, DC combiner box if you have, bus bars if it is overheating, what is happening on how this calculation will goes around. All this will be discussed. It's in preventive maintenance, the monitoring, again the monitoring and the data analysis. This is comes under completely O&M, the operational and maintenance, that you have to perform all this maintenance part in every 5 days. So next comes to the troubleshooting again. If there is an shading, soiling, or electrical fault, so you know that if something is going issue with your system, that is common, cause common issues, that you had to work on that. You had to clear the shading, clear the soiling, electrical faults, like as in you can see that is potential degradation will happen. This all the degradation is losses, it comes under the system losses. Yeah, the production that itself it will take around me to explain around 15 minutes what is the actual issue of the potential degradation from the source from your solar panel, how you can reduce it, how you can work on that. So these are the different kind of things that we had to discuss, but I have tried my best possible way to understand it, this basic about the system. Inverter issues, electrical codes, voltage fluctuation. If there is any voltage fluctuation, your system or inverter will stop producing power. It has to be stable. Performance drop, degradation, and temperature. As I said, the temperature is the major component in the field of solar that you have to understand, and you will see that moreover in future that a lot of projects will come around to decrease the temperature of the solar panel to increase the efficiency or increase the performance of the solar panels. Like as an advance, what you can do, you as you said, you will be using the thermal imaging to check the termination of any connectors at the high voltage. You will see what will be the temperature of that, and you can see the temperature of the solar panels, any hotspot, and you can IV curve, that is current and the voltage curve tracing for each and solar panels. If it is reduced, then this solar panel is not producing. You have to find out which panel is not producing. You have to replace it. These are the troubleshooting that you need to get into the field of solar. Okay, this is the end of the session over here. Please, if you have any question, please let me know.
Yes, for solar panel, for the for power plant or for domestic, the same power panel can be used, or there's a different for the power
Ah,
plants and the domestic level.
panels will be the same. There is no difference in the solar panels. Inverters will be changing and your capacity will be increasing. So in your domestic, as I given one example, that is 4.5 kilowatt, right? So you can consider it's a 45 kilowatt. Let's see how the panel differences. You can just increasing. I have just given you prototype to understand the scenario. So in the large scale project, so if it is getting very large, so you will be seeing lot of losses, lot of differences, lot of problems in between there, transportation losses. How does we can able to understand that you have to design it? How can I get the
For
inclination and angle of my solar panel in my site? Yes, I said you the tilt angle and the difference in the pitch or the difference between the two rows. Yeah, that is a complete calculation around. We had to go with that. So in the next session, surely I will try to explain you all those details with the calculation itself. I think I tried, but it will take you a lot of time if I go with that. Like tilt angle, right? Someone is asking the tilt angle. So it depends on the latitude and the longitude of your location. According to that, we used to calculate. There is a set of calculation. This calculation is not set, but there is an assumption that has been driven. We had to calculate according to that itself. That will give you the optimal. So the sun direction will not be someone asked the question right for the tilt. The sun direction will not be same throughout the year. It will be changing. There will be an elevation over there. We had to calculate that elevation. The tilt angle will give you the like as an average value over there. It will not give you complete exact value. Average value, according to that we have to install it. So that's the reason we have the solar tracking system, single axis, dual axis tracking mounting system that has come across. So it will track according to the sun direction. Yeah. Next question.
for solar power plant, serial and parallel, which solution is recommended for efficiency point of view?
So efficiency point of view, it's depend on the type of inverter that you are using. If it is asking like consider if I'm going with a 250 kilowatt of inverter, right? So your inverter will ask around 600 volt of DC input. So you have seen in the data sheet it is giving around 45 volts, right? We will see 45. Let me calculate that. 600 volt of input for the MPPT for that inverter. 45. Let's see. So you can utilize 10 solar panels for the single string in the series connection. There is an Sunil asked question in an on-grid system. If there is an off, can we still use the solar energy in-house purpose? So right now, if it is driven by, if it is provided, if a confirmation is provided from your Bestcom or electrical company, you can't use that. But there is an option which are coming. If you use a three-way switch or which are controllers, yes, you can completely disconnect from the grid system, and you can utilize if you have a reference grid. You can use from your batteries or from the other source. Yes, you can do it, but that option is not available right now. Soon you will be get kind of controllers or three-way switch in future. And the next, we have already installed 440 watt of panel string now. We can't connect 580 watt panel string in series or parallel. So it is Asif is asking this question. So is, as I said, the voltage and the amps will be changing for each and every solar panel. If your system is designed for the 440 watt panel, if the voltage and amps is matching to each other, yes, you can install it. But if it is not, you can't install it. Yeah, whatever the system that has been, mostly if it is string inverter, it will be in series, not in the parallel. Okay, next question, that does Sunil again. Okay, does the inverter do the switching? The switching, that kind of inverter is not available. Because of that, it's called as an anti-islanding. Anti-islanding is a must and should. If any inverter company is coming into the field, there had to be an anti-islanding. If there is a no grid, your inverter should not produce any kind of energy. If it is producing, it will be considered to be a failure. They have to be out of the business. So that is not possible. But if you have some kind of reference voltage that you can give to the inverter, it will start producing. Inverter need only AC voltage and the DC voltage. If both are available, inverter will start producing power. If it is not, if anyone is there, if it is absence, inverter will go into the shutdown mode. So can I get the grid my DC earthing from solar panel? Okay. SP, sir, can I grade my DC earthing from a solar panel with my AC? So AC earthing and DC earthing, it should be always be separate. Because the DC earthing, if there is an lightning can be happening to your solar panels, if it is striking to that, if you have a different earthing, that will help you. Otherwise it will also affect your home appliances. So better you can go with the two different kind of earthing. uh, Shakib, in series connection, what would prefer for utility base or daisy chain connection? Daisy chain connection. Yeah, daisy chain connection only. Daisy chain connection. So in the micro inverters is coming around the daisy chain connection. So that would be preferable. And moreover, you will see in the future, in coming within 1 or 6 years, sorry, 1 or 6 months, you will be seeing a lot of new components which are coming that will be completely depend on the daisy chain connection. Yes, you can see that. Any question apart from this? Okay, Sunil again. For large scale design, 120 to 100 200 kilowatt system, use multiple inverters, so small rating is good. Or uh, small rating is good because you will be not facing any kind of DC losses, but there will be an AC losses as well. But if you are using a small, that would be fine. But it's depend on the economical condition. If the customer is fine with that, yes, you can go with the small rating. If he's not good with that, yes, you can use a single kind of inverter, like it will become as an central. Of the on grid system, how can we do this switching? In switching is not possible right now. So switching is kind of we need to give the reference voltage to the microinverter. Uh, if location is offshore, what type of solar panel? All panels are like as an IP67, I think so. That can be used anywhere. That can be used inside the water as well. But it's depend on the type of panel. You please refer to that data sheet. It will be given there itself. Many of the solar panels that can be installed on the like also an floating system. Yes, you can use that. There should be no issue. Any question?
Yes, in the start you tell us that in the yes, in the start you tell us that the solar panel efficiency will be affected due to the temperature.
Exactly.
So in the data sheet, yes, in the data sheet, can we see like any like temperature rating, like on what temperature the panel will work with a good efficiency? Any temperature range is available on the data sheet or no?
Yeah, it is available. I think I have showed you that. I think so. Give me a minute. Let me show you that again. Can you see this?
Yes, you can see.
Okay. So temperature ratings over here. Can you see this? Nominal operating temperature 43 degrees Celsius. Nominal operating cell temperature. Normal operating cell temperature. Maximum operating cell temperature is 85 degrees Celsius. If it is going beyond to that, your system will not produce any kind of energy.
Okay, I got it.
Does bifacial panel have proven result? Yes, obviously. The bifacial panels are good. It's depend on the type of installation that you have done. Okay, I think you have given me a lot of time to understand the system.
One more question, sir.
Okay.
Using bifacial modules over the tin shed is beneficial, technical point of view.
On what? Can you repeat your question?
Using bifacial solar panels over the tin shed roof
There should
is
be there should be a difference between roof, the landing roof and the solar panel. It's a reflection where on the reflection your backside of the panel will start producing power. If there is no reflection, your panel will not produce. It would be like as in the temperature will be higher at that time. So if you are designing with a bifacial, that would be the complete difference. So the bifacial where it is more utilized is if you have a high-rise structure or if you're using an tracking system.
if we are using some small structure like 100 mm size, okay, so in this case bifacial is beneficial or not?
Bifacial is beneficial, but again, it is completely depend on the calculation of that mounting structure that we need to design it. So that calculation will take some time. So in the next session, when you've been in the next session, I will share all that details to you.
But sir, when someone is installing over the shed,
Mhm.
so not more sun rays are dropping into the tin shed and reflecting to back of the solar panels.
It is
In this case, bifacial is not a
beneficial.
good idea.
No, this is a simple understanding, right? If there is no space, no, nothing. That's the reason for bifacial panel, there should be a complete different mounting structure. For that different mounting structure, there will be different calculation, different designing calculation. That is mounting structure calculation is completely different.
Okay, thank you.
The battery, Sunil, again for the battery based system, does the solar panel changes according to the days of? Yes, obviously. That is a the different design. Surely, I will try to explain that complete design to you. Yes, the panel capacity will get changed. battery capacity and the system capacity. Everything that is kind of complete different design. There is an off-grid system. It's not like as an on-grid. Okay. Okay, then. I really thank you for all being through the session, and you have given the very you have really been very interactive. Then only we can able to I can explain a lot of things to you all. Okay. Do you have any other further questions?
Next session will come.
Surely, surely. You had to speak with Muskan for that. She will assist you further.
Thank you.
Okay. Thank you very much, and thank you all.
Hello,
Yep, I'm here. Mic
thank
on.
you. Hello. Yeah. Yes, I really appreciate the lecture. You know,
Yeah.
it was excellent. Let me put it that way.
Yep. Yep.
But there's one thing I want to appeal. Can you send us the slides
Yep. If
so
you
that
want
we
to.
can even go through again?
Okay.
And I really appreciate you. Thank you.
Sure. 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 That.
So the slide, are you sending it, Ross?
Yeah. Yeah. The
All right. Thank you.
Muskan will share to you. Yep. Surely.
Thank you so much.
Thank you very much for that. All right. Have a great day and good night, good evening, or good day. It's depend on your location. Bye bye, all.
Thank you, sir. Thanks.
Bye bye.
Bye bye.